Hi, I'm Samuel. I'm a PhD student focusing on natural language processing research, a little bit different to what is expected on the final project. Here I will present to you about symptoms of human brain disorder that actually happens in a conversational AI system. In this presentation, I will be focusing on these three things. The first one is language, the second is prosody, and then the third one is long-term memory. Let's see the language processing module of an AI brain. On the left figure, we can see in left hemisphere of human brain, we can see there are Wernicke area and Broca's area, which corresponds to language understanding and language generation. And on the right hemisphere, on the area corresponding to Wernicke and Broca's area, we actually have prosody understanding and prosody generation. And how does this language processing module in AI looks like? A little bit different to what we have in human. As see on the right, we can see there are four different modules to process language in AI. The first one is speech recognition module, and then language understanding, language generation, and speech generation. So speech recognition module takes audio signal as the input, and it could extract some prosody features and then generate text. The text will be processed by language understanding to generate context for the language generation module, and then language generation module will produce response text then converted to audio signal by the speech generation. So in terms of language, there are one main problem that I think still exists in AI, lacking the capability of language understanding and language generation. I mean, we have this module, but this module is kind of imperfect because how we learn language is different to what human learn. And the second one is about the prosody. So in terms of prosody, actually we are lacking in both of prosody understanding and prosody generation. So in, we have some prosody understanding unit, but the problem is given an audio signal, it would be much easier to extract the text information for human rather than labeling in which time frame what prosody that are occurs on that moment, at that very moment. And even further, there are very little work related to prosody generation. It's also probably the same reason as before, which is it's very difficult to have prosody labeled data, for prosody generation. Next, we can go to the long-term memory of an AI system. To recall, in human we have two different kind of long-term memory, which are implicit and explicit. Implicit consists of procedural and emotional memory, while in explicit we have episodic and semantic memory. How does the implicit memory of an AI? As far as I know, there are no such thing called emotion memory in AI. But for procedural memory, it's actually a very active research right now due to a new trend of technology called deep learning. Uh, Now, a machine can actually learn how to walk, to grasp, to move. And one of the example is this robot over here is the robot made by Boston Dynamic, and it can work really well. Now, let's go to the explicit memory. Does AI actually owns it? To answer that question, we need to see the memory formation of an AI. First, let's recall the human memory formation. We have a working memory, and then we will send it to hippocampus, and then we will encode those memory into an episodic or semantic memory stored in the neocortex. In this diagram, if I add another factor, which is environment, the figure might looks like something like this. So how does this figure looks like in AI system? So there are quite different between human and an AI memory formation. In AI, we don't actually have hippocampus, but related to episodic memory, we sometimes use something called replay buffer, which stores something similar as an episodic memory, which comprise of the state of the AI, and then the action that it takes, and then the reward that it gets during those experience. And this replay buffer is pretty inefficient because it stores a lot of raw data, and also it's only used for learning. This memory cannot be used for like recalling some significant thing that happens recently. So it's very limited. And then the second one is the semantic memory. So AI don't actually have real semantic memory. but it can get some prior knowledge from external data source like database or API. Sometimes this prior knowledge can also be written by the model. Like if you have a ticketing system, you can order a ticket, or if you have a personal assistant, it can set some reminder and stuff. But this capability is very inflexible and rigid. Let's say the environment give the AI some new concepts. The AI couldn't learn the experience by itself. So the AI have the memory of all the previous knowledge, but it cannot really make a new concept. So in some way, it's kind of similar to amnesia in human. To conclude, I've described some issues of the current conversational AI system in terms of human neurobiology. So there are at least 5 problems that we have discovered. The first one is imperfect language capability, poor procedure understanding, lacking of procedure production, and then limited and inefficient episodic memory. And maybe I can say it is like partially amnesia. And there are actually many other issues in AI, like lacking of common sense, lacking of generalization, and also if we have all this stuff, it's very difficult to orchestrate all the system into a single system. So yeah, that's all for my presentation. Uh, Thank you.